Okay, so I want to cover three concepts of investing. First concept is simple interest versus compound interest. I got a whole lot of numbers here, like, oh my goodness, what's going on here? When we say interest, think of, I just explained this the other day to somebody. Think of you need a hand sanitizer for your house. This is the time it's coronavirus time right now, and I'm at home, and you need some hand sanitizer, and it's $10. All right, and you only have $8, and I meet you at the store. I'm in the store too, and you're wanting to buy hand sanitizer. Come right over, Mr. Reardon, Mr. Reardon. I really need to buy this hand sanitizer. It's $10, and I have $7. Can you loan me three? Well, yeah, sure. I'll loan you three. But next week I want $4 back. So I'm going to loan you $3 right now, and then next week I want you to pay me back four. Wait a second. I thought you said you only get a loan three. Yeah, but I want you to pay me back four. Well, how much extra did you pay me? You paid me $1 because you're using my money. I could have used that money for something else. Instead, I had to give it and loan it to you at the store. And so I'm charging you what's called interest, or the fee. That's the fee you paid for using my money. That was a lot of interest, by the way. But I really like that definition of interest as being the fee you pay for using someone else's money. Now, when you take out a car loan or a home loan or pay interest to a credit card or whatever, you're using somebody else's money. And they're going to demand a fee for that. That fee, again, is called interest. All right? Now, when it's you investing your money and somebody's using your money, they're going to pay you interest. That's when interest is working in your favor or on your behalf. Okay? So we're going to look at this model, simple versus compound interest. And we have, let's say, an interest rate of 9%, and this is over a 20-year period. Okay? And in each case, we start out with $10,000. Now, with simple interest, we're going to take 10,000 times 9%. So over here, let's see here. I'm going to come over here, and I'm going to use this like as a whiteboard, so bear with me here a second. We're going to do 10,000 times my beginning balance, also known as my principal balance. Again, this is me investing something. So someone is using my money to invest in, all right? And they're going to pay me interest, so they're going to pay me a fee for using my money. So I have 10,000 times something. I've got 9% up here as my rate of return on an annual basis. So what is 9% as a decimal? Well, again, if you're bad at decimals, you have 9.0, let's say, percent, right? You need to move your decimal place over 2 spots, 1 and then 2 from here over to here to come up with 0.9, not percent, it's 0.09. 9% becomes 0.09. And what does that equal? That equals $900. Not a bad little chunk of change for a year, huh? And so with simple interest, every year we got a $10,000 investment. Every year we make $900. We make $900 for 20 years with simple interest. We just start every year we apply our 9% to that same $10,000 initial balance, and after 20 years we have $28,000. That's pretty good. That's pretty good money. 9% return is about an average stock market return. Although we've been getting beaten up, of course, lately on the stock market. Let's talk about compound interest. First year, $10,000. 10,000 times 0.9 is 900. At the end of the year, 10,900. Think of this as like December 31. On December 31, we have an ending balance of 10,900. On January 1st of year 2, the next year, we have that same balance. The ending balance of year 1 becomes the beginning balance of year 2. But with compounding, things are a little bit different. With compounding, we apply our 9% interest rate to our new compounded balance. We add the interest from our first year, come up with a new balance. And now we're going to apply 9% to 10,900. So now over here, if we take 10,900 and multiply by 0.9, we got $981. All right. Okay, I'm going to drop that down here. Okay, we have $981. And so we have to take our $981 and add it to our initial balance of $10,900 for that year. At the end of the year, we have $11,881. Okay, well, that's awesome. Well, what happens when we get to the next year? Let's check that out. Well, now year 3, we start out with $11,881, and we multiply by that same 0.09. And with compound interest, we have a new compound balance, or what's called a principal balance, of 11,881. 9% times 11,881 is $1,000.69. And you can see that over time, the amount of interest with compound interest grows, and it doesn't just grow straight line like simple interest, it grows exponentially, or think upward curve on a graph. So our money is growing much quicker, and that after 20 years with compound interest at 9%, compounded annually, meaning that every year we are recalculating our balance that we're applying our interest to. We're earning interest on interest, and after 20 years, we have $56,000 in our investment account compared to just barely less than half with simple interest. And I know Dave Ramsey, the financial guru, talks about compounding interest as like one of the great wonders of the world and one of the most amazing things he's ever seen. So that's compound interest. All right. So I'm going to switch gears here a little bit. I want to talk about something in kind of relationship to the compound interest. It's called the Rule of 72. Rule of 72. Rule of 72 is this. I'm going to do some playing around here. All right. Rule of 72 is this, is how long will it take to double my money given annual compounding and a rate of return. Okay? How long will it take to double my money given annual compounding and a rate of return? Well, annual compounding, again, going back to our simple versus compound interest example, this is where every year we're recalculating our balance with compound interest, and our amount of interest, or the amount the investment company is paying us to use our money, is growing at an increasing rate. So you can see this first year it grew $81. I'm just doing this math here. Second year it grew $88. Third year it grew $97, and so on. It is growing at an increasing rate. We have some math working in our favor. Okay? So with Rule of 72, we're recalculating, we're assuming that our money is being compounded every year. So the question is, given an investment at the beginning, how long will it take to double my money? Okay, well, let's say our rate of return, for laughs and giggles, is 8%. Okay, all right. The Rule of 72 is just quite simply this. You take, and I maybe move this over a little bit here. All right, expand that out a little bit. Okay, the Rule of 72 is just simply, we take 72 is our numerator. Nothing fancy. 72 is the numerator. Why? Because it works. That's really the best answer I can give you, because it works. That's why they call it the Rule of 72. The 72 is the denominator, the numerator, I should say, math terms. Numerator, the top part, is 72. The denominator, or the bottom part of our equation, is our interest rate. Don't convert it to a decimal. Just take it as a regular number. 8%, I'm just going to put 8. All right? So, how long is it going to take me to double my money? Well, I'm not really sure here. We're going to find out. We're going to say equals Ooh, can I like center that? That might be kind of fun. Whoa, Reardon, come on. Let's do this. Equals equal sign. All right. Maybe we'll center that. Ooh, that's fun. And we'll maybe make it bigger. Ooh, like that and bold. So 72 divided by 8 equals, again, we're talking about something related to years. Okay? Something related to years. Well, what's 72 divided by 8? Calculators, please. Not sure. All right. Well, 72 divided by 8 is 9. So it's going to take me 9 years to double my money. Let's make that bold just for laughs too, all right? 72 divided by 8 is 9 years. Given annual compounding, here is my rate of return. Given an 8% return, it's going to take 9 years. Well, how do you know that? Let's go back to our compounding example. Let's say up here my interest rate is 8%. Are my calculations down below here? They're not. I might have to expand this out. No, I'm not. I'm going to be good here. I'm good. Let's say my interest rate is 8% up here instead of 9%. Change that to 8%. Well, come over and look with me at this compound interest over here. My beginning investment is $10,000. Remember, rule of 72 is how long will it take to double my money? Okay? How long will it take to double my money? Now, the principal or the beginning balance is not important. But my beginning balance is $10,000. What is it going to take for me to double my money? What does my amount have to be? Pause me if you need to think about that for a second. If I'm going to double my investment, again, financial people use this ratio a lot. If I'm going to double my investment is how much? $20,000. Well, if I go down column H to my ending balance, what year am I closest to $20,000? Well, I come down here to, you could say, oh, year 10 is 21. No, that's not. Here, year 9, 19,990. That's almost exactly double 10,000. It's just $10 short of 20,000. That is perfect. All right. Well, what did I calculate before for my? It took me 9 years, 72 divided by 8. It took me 9 years to double my investment. And I just proved that out here. What if we do this? What if we come back here and say my rate of return is 6%? Rate of return 6. Let's put some right stuff in there. 6%. Okay. I'm going to pause just a second. I'm going to take my numerator away over here. We're going to recalculate that. Get rid of our years. Okay, what's that going to be in years? How long to double my money? Again, 72 is my numerator on top. What's going to be on the bottom of my ratio? You guess 6. You're correct. I'm just converting my interest rate into a regular number. 6. What's 72 divided by 6? You're right. 12 years. It's going to take me 12 years to double my money given annual compounding, given that each year I'm recalculating my amount. Let's prove that again up here. Interest rate 6%. Come down here again. What's double my investment? 20,000. Again, the amount doesn't matter. I could say it's 3,000 or $10 or whatever. It doesn't matter. Well, let's see. Let's come down here. It looks like in year 12, I'm the closest. This is like that's like $1,000 off from 20. That's not the answer. 11 years. 12 years is just about $122 over, but it's the closest. So in year 12, I'm doubling my money, and I just proved this equation here. Let's do one more here. What if my rate of return is 3.4%? 3.4%. What's that going to come out to? Calculators, please. 72 divided by 3.4. Well, you know what? I'm going to cheat over here because I have no idea what that is. 72 divided by 3.4, correct? I'm going to cheat and use Excel. You can use your calculator, or you can use Excel too if you want to do that. Ooh, it comes out to 21. I'm going to round that to 2 decimal places. 21.2 years. I'm not going to pop that into my model back there, but that's how long it's going to take. Is 3.4% is not much of a return. It's going to take a long time given annual compounding. Maybe I will put that in here. 3.4%. All right. Let's do something here. We're just going to go with that. That's actually 3.4%. Trust me on that. Let's make that increased decimal. Excel 101, 3.4%. My model runs out after 20 years. You can see that year 20 I'm getting close. I still have a ways to go. So it's kind of, again, proving that it's going to take 21 plus years to double my investment. I kind of ran off the rails there with my example. Hey, this is live demonstration. Give me a break, okay? I'm trying. So that's rule of 72. Okay, 72 in the numerator, your interest rate, whatever is stated, your rate of return. In the bottom, we're assuming annual compounding, and there you go. Okay, last thing I want to do is I want to talk about change of percentage. Let's see here. Let's say that I have a stock in Summit Corporation. By the way, if you think I'm making this up on the fly, you're absolutely right. I am just making it up as I go along. Have a fun time with this. Summit Corporation, and let's say that before this whole mess started and the COVID thing took over, let's say that on February 24th, seems to be about the magic number before things blew up, my beautiful Summit Corporation stock was trading for 92.31. We're talking stock price here. 92.31 per share. Today, April 1st, it's trading for, most of them would be like, let's say it's trading for 58.84. Making it up here. Okay. February 24th, 92.31. April 1st, 58.84. Now step back just a second. Don't do any calculations. What do you predict's going to happen here? First of all, did my stock price go up or did it go down? Reardon, it's obvious. It went down. Thank you. And what we're doing here is we're doing something called percentage change calculation. Percentage change. Let me format this. Hold on here. Percentage change calculation. All right. All right. And so I want to calculate percentage change. Where you're going to guess if it went down, is my change positive or negative? Well, Weird, it's negative. Yes, I know it is. You're correct because it went down, right? So we can predict that. Also, did it go down a lot? Well, yeah, it kind of went down quite a bit. It's not going to be a ginormous amount like hundreds of percentages, or it's not going to be a teeny amount like 3%. We can predict that. It went down quite a bit. It went from $92 to $58. So if you're not even good at math, it's okay. Start with a prediction. Just kind of look at the data and go, this even makes sense. Now, if you're really weak at things like this and aren't very good at math, I understand. That's okay. Let's walk through this. If I was you, when I come faced with a percentage change problem, I would create a timeline. Create a timeline, like so. All right. And on this timeline, we're going to have 2 points. We're going to have x1. Maybe I'm going to format that and write a line. And maybe over here I have x2. Now I could be really fancy with my formatting and all that. x1, x2. Points in time. All right, on my timeline. This is my beginning point. This is my ending point. My time is moving from left to right. Okay, so the first thing we need to do is, given this problem, which one of these, which is x1 and which is x2? Again, if you're like bored and going, Reardon, this is just so obvious, I can't believe how horrible this is. Okay, I'm sorry, but some people just aren't naturally gifted at this kind of stuff, and that's fine. Okay, so which one is x1? Yes, you guessed right. February, the earlier date, that is x1. That makes, of course, April is x2, my ending date. formula looks like this. So I'm going to say formula, or let's do this percentage change formula. Okay. We're going to take, again, the first thing we need to do is did our stock value go up or down? Well, we need to take our ending point. Format this again. We need to take our ending point, x2. Man, that was a funny thing there. x2 and subtract our beginning point, x1. Right? That's our formula. x2 minus x1. Where did we end minus where did we begin? Now, don't get tricked by this. This can be positive or negative. Either one. Okay? Our denominator, this is our numerator and our ratio here. Our denominator is, well, when we say percentage change from what? From what? Where did we start? That's what we're changing from. Not the bigger number or what looks cool or whatever. So where did we start? We started at x1. Let's get my formatting down here again. I'm just doing this on the fly. It's okay. x1. There we go. x2 minus x1 divided by x1. Well, weird, what in the heck is that? Well, let's go check it out. So we end up with, in this case, we end up with x2 is my ending point, 58.84, 58.84 minus 92.31. I need to do more formatting. This is like Excel at its greatest, okay? And I need to get rid of that little line there and mess around here and whatever. Get my equation back into place where it was. There we go. Okay, all right, x2 minus x1 over x1. Over here we have 58.84 minus 92.31. We'll extend that out a little bit there. And we're going to divide by what? We're going to divide by x1, which is 58.84. Okay, well, what in the heck is that? Well, let's come over here. Say, what's 58.84 minus 92.31? Good question. You know what my favorite math answer is? The same it was yesterday. Really funny. Okay? All right. So over here we're going to say 58 equals 58.84 minus 92.31. Ooh, that's minus 33.47. Again, we predicted that the stock price went down, right? Yes, it did. Okay. And what is x1? Oh, Reardon, over here you messed up. I did. And you caught me, didn't you? Like, Reardon, that's x2. Yes, it is. This is live. Okay, I'm going to go back and fix my mess here. 92.31. That is x1. That was my starting point. Sorry about that. I just confused you. I just want to make sure you were awake. That's what every teacher says, right? Yeah. So numerator 58.84 minus 92.31. That's my change of my price over time. I divide it by 92.31, which is x1, my starting point. So over here I've got minus 33.47, which was x2 minus x1, 58.84 minus 92.31. And down here I'm going to put 92.31 in my ratio. Okay. And coming over to what's my final answer going to be? Let's not put an underline on that. Let's see here. What do I end up here with? I end up with minus 33.47 divided by 92.31. Minus 33.47 divided by 92.31 is minus 0.3625. Okay? Now, what is that as a percentage? Well, again, if you're not good at this, if you're going to convert a decimal to a percentage, either multiply by 100, or move decimal 2 places to the right. Okay, so 2 places to the right, over there, and don't lose your minus sign because it is a negative. It was a decrease. So I would say this is minus 36. I'm going to round this to the nearest tenth. Minus 36.3, that's what 0.258 is. Minus 36.3% would be my percentage change. My stock price went down. I lost about a third of my value, more than a third of my value. It was substantial, and there you go. All right. Now you might want to refer back to this periodically, this video periodically, if you struggle with percentage change calculations. Okay. All right. So I will move on here, but again, we've talked about compound versus simple interest. We've talked about rule of 72, and we've talked about percentage change. And I hope you've enjoyed this video.